So a Cat 4, here's our categories. So a 600 volt, that means the maximum you could use that range, 600 volts on your meter, right? You understand that? And if it was a Cat 4 meter, it could handle a surge using UL, which is what we use. It could handle a surge of up to, if it was 600 volts, it could handle a voltage spike of up to 2,500 volts. And that's what the category is. So the category of a meter gives you how much of a spike it can handle. You know, we get spikes on our power grid all the time. And the closer you are to the actual distribution, the worse it is, because the spike diminishes over distance, right? You understand? So basically that's what it says. A Cat 1 meter, a Cat 1 meter should never be used on the distribution side. It should be used over here on these electronic devices, right? Because you're way into the building now, right? You understand? And you're going through a lot of wires and a lot of different breakers and stuff like that, and the surge will diminish over this. So this is Cat 1 meter. This is where you should have a Cat 2 meter, single phase, like appliances, PCs, TVs, and other household loads. Outlets located at least 30 feet from a Cat 3 source, more than 60 feet from a Cat 4 source. Now, Cat 3 meter, this is where we're starting to get into 3 phase, right? 3 phase. So to measure 3 phase, you need to at least have a Cat 3 meter. Everybody understand that? Yeah.
On this meter show Cat 3. So
yeah, but you look at the Cat 2, it's probably going to say 1,000 volts, and the Cat 3 is probably going to say 600. So if you get into a Cat 2 source, right, you understand, then you can go up to 1,000 volts on your scale. But you can't come over here and get 1,000 volts. It drops down to what, 600?
Yes, it's correct.
So it's probably got 1,000 volts Cat 2, and then it's got 600 volts Cat 3. So that means I shouldn't measure my meter will measure over 600 volts, but I shouldn't measure, right? If I measure over 600 volts, then it's no longer, I don't get the protection of a Cat 3 meter. It don't mean you're not going to have any problem, right? You understand that? It's just that you got to be careful now, because if you get a voltage source, the meter could go up. That makes sense? Yes or no? So what the category does is the category tells you how much a surge your meter can handle without blowing up in your hand. That's what it means. So to know it, you would have to have what? You would have to have this chart. So it says Cat 3, 600 volts. Cat 3, 600 volts. It means I could handle over here, Cat 3, 600 volts. I could handle, sorry. So it says it could handle a 6,000 volt spike. As long as you was not measuring anything over what? 600 volts. Everybody okay? And this don't show, here's Cat 4. The only Cat 4 they show is over here on IEC. So see, on a 600 volt scale, if it's a Cat 3, 600 volts, then it could handle what, 6,000 volts. That makes sense. So what it's telling you is it's telling you get Cat 2 protection, or Cat 3 protection up to 600 volts. If you measure something over 600 volts, then you don't get that protection. Right? That makes sense. Or that's Cat 3 on yours, right? Now Cat 4, we can move over to the distribution side. So Cat 4, we could actually be over here measuring our down drop coming into our house, right, from the distribution side, over there on Cat 4. We don't need a Cat 4 meter here because we're well inside, right? We're a long way from the Cat 3 source. I think our down drop comes in way over yonder on the other side of the building. So Cat 3 meter is great. But we are going to do what? We are doing 3 phase. I'm doing 3 phase. I need at least a Cat 3 meter. Cat 3 600 volt for this class is fine. You're measuring 208 volts. Any question there? That gives us the watt. The category of the meter tells us how much of a surge it's going. The category of the meter should be somewhere down close to your watt, down close to where you plug those terminals in front of your lead meter. So this, did y'all see this? Did they show y'all this when they did the meter? There, I don't know, I think I got this offline. I need to make sure that this gets into the PowerPoint. I don't think this is the PowerPoint that comes from Snap-on. This just tells you exactly, I think it tells you where you can measure, but I don't think this is in that chart for the Snap-on either, where you can see exactly where these things give you different protections at, right? Does that make sense? Now, whether it's UL or IEC, this is IEC, this is international, this is local. Your meter should have either one of these or both of them on the back. That makes sense? You take the meter over, you should be able to see IEC, and you should see UL. If all it's got is UL, then you're going to be on this side. If it's got IEC, then you use which one of them is the biggest, right? That makes sense? And this hadn't been around. I got meters at home, so this meter right here has been around for a while. So this meter's been around for a while. Okay. And this meter goes all the way up to here's volts, 700 up to 1,000 volts DC or 750 volts AC. And then down at the bottom, so this is only a watt. Yeah, CAD2 meter. So that means I shouldn't use this meter. I can measure on the other side of my transformer, right? But I can't measure on, I shouldn't use it to measure on three-phase side, right? Everybody understand that? So we're going to go through a transformer. All our controls themselves, our controls, the relays and everything, are 120 volt relays. So what we do on our trainer is we'll bring our three-phase out, we'll come in and talk. It's real dangerous, especially on a high voltage circuit, plugging these things into a circuit. Oops. What happened to my... Oh, it's gone, guys. Y'all see my lid? So here I'm trying to use a meter. I got my meter leads right here, and I'm trying to make a meter reading. I'm holding my meter in my hand. So what do I try to do? I try to make my connection with one hand, right, like this. That's dangerous, right? You understand that? So what we want to do, or teach you in this class, is normally what we do is we take, and AC, by the way, AC, these leads mean nothing in AC. Black and red mean nothing in AC. You can use the red lead as your common just as well as you can a black lead, because AC technically has no polarity because it's changing so fast. So a lot of people say, well, you take your black lead, but in AC it don't make any difference. But what you're going to do is you're going to take one of these meter leads and you're going to clamp it over here to L. You're going to clamp it over on L2. And then now what are you probing with? You're probing with one lead. So when you buy your meter, it's going to come with some alligator clips where you can put it on one of your leads and you can clip it somewhere on what? L2. And L2 is L2. It's going to run through your entire circuit, right? You understand? So anywhere you got L2, you can clamp that onto. And then now you're going to make voltage measurements relative to what? One lead and one hand. It's also dangerous to do what? Can I help you? No, it's not. So on digital meters though, if you hook your leads up backwards on DC, it's just that instead of measuring positive voltage, you're going to measure what? Negative. Digital meters don't care. So you'll see me jump in a circuit and I'll go from this side to that side. It's on this side it might have measured positive, on this side it measures negative, but it's going to prevent me from moving my other lead around. So what we could do on here for troubleshooting is we're going to take one of our leads, right? And we're going to connect it to L2. And then we're going to do what? And then we're going to probe back to L1. Are you okay? Make sense? Current. What do we have to do with current? We have to break the circuit, right? You understand that? And make the current flow through the meter. We got to really be careful. We never put this across anything because it has almost no resistance at all, right? You understand that? Make it flow through the meter. Now, since this is a series circuit, it's literally pretty easy, right? Now, measure resistance, what do we have to do? Oh. Yeah, but with power what? Removed. Power is always supposed to be removed. Because when you put your meter, a voltmeter, this guy turns into a current source. And if you force current through your meter, you could damage the meter. So make sure, so what two measurements do we make across? We make voltage measurements across, and we make resistance measurements across. Voltage measurements is with power on, unless we're trying to verify it. One thing that you learn real fast in electricity, if just because you go out and pull a fuse, or just because you go out and turn a breaker off, we don't assume that that's the right breaker. We always verify that power has been removed, right? You understand? So always. Y'all hear that? Because that relay in there could have a stuck contact on it. And I hit that button, it opens up two phases, but the other phase is stuck on because the contacts are welded together. So what I want you to get used to doing is doing what? When you turn it off and you start getting your hands into that circuit, because you don't have to have those gloves on with power off. The only time you need your gloves on is when you're in an active circuit. The only time we're going to be in an active circuit, guys, is when we're making voltage measurements. So you're not going to wear your insulating gloves all the time, right? You're going to wear your safety glasses each time you're over there, but you're not going to wear your insulating gloves unless you're in the circuit with what? Power on. Everybody understand that? So any questions so far? So across for voltage, with voltage on or off, but if we're going to measure resistance, we're going to always make sure that the power of the circuit is off. You might even verify that with your voltmeter, right? Now, to make a connection for an amp meter, you're going to make the connection with the power off. So you're going to turn the power off, right? Understand? You're going to make your connection, right? Here you probably need to use two clamps, right? Clamp it on here, clamp it on there, and turn the power back on. You measure the current. We're going to be doing this. We're going to measure the current into our motor. We're going to deliberately do what we call a single phase and a three-phase motor, which is not good, but we're not going to do it very long. We're going to see what happens with the current. These are only, it'd be hard to use a clamp on that meter. You might try one because we've got plenty of cables where you can loop it around. This guy right here is 1.6 amps at 208 volts. Now that's your run current. So on your nameplate, it's going to have something called amps. That amps is the run current. That's not the start current. That's the run current, right? So yeah, we might be able to measure that with a clamp on. We might need a meter. But you're gonna have to loop the wire, right? You understand what I'm saying about looping the wire? And we have digital meters, right? We have auto ranging meters, which are nice. Auto ranging meters are usually slower than manual ranging meters because it's got a range. So it tries to go up to whatever count it is. So this would be a 4,000 count meter, guys. This is a really good meter. This is a Craftsman. Our meters are either going to be 2,000 count, they're going to be 2,000 count, they're going to be 4,000 count, they're going to be 6,000. And you can tell what they are depending on where they range. So if it ranges on 3,999, then it's what we call a 4,000 count meter. So the more counts the meter has available to it, the more it costs. So a 6,000 count meter would cost more than a 4,000 count meter, which would cost more than a 2,000 count meter, right? So this is the 4,000 count meter because it's up there at 399. So what happens is it would go up here and go 3.99. It would drop back down to 0. It would move the decimal point over, and it would start counting again. So auto ranging meters are slow. And if you get to where it's between two ranges, them suckers go crazy. Because they'll be doing what? They'll be constantly switching between the two ranges. So just about all your auto ranging meter has a hold feature on there. And what you can do is you can prevent it from changing ranges. So you can actually select one. These are analog meters, or what we call. These are still out there. I still have one. Huh? Oh yeah, there's one. These things are a lot harder to read because you got different scales for different measurements. So you got an AC range, you got a DC range, you got an ohm range. So you got to figure out which scale to use depending on what you measure. But once you learn how to use them, these guys do. And if you're in communications, these guys are probably going to like that range. And we looked at a clamp on meter, right? So we got a digital clamp on. Looks like it can't be a 2,000 count meter because it would range on 199. So we have analog clamp on, very cheap. We could use these. They're not really extremely accurate, right? Huh? Well, you'll know enough. Like on three-phase motors. Three-phase motors, if the motor's okay, then all three phases should be pulled in the same current. So this would be an analog meter would be a lot easier to see because all you're doing is seeing the dial comes up in the same spot, right? Tuned circuits, communication. You're looking for something to peak out, or either you're looking for the dip when it hits the minimum level or when it hits the maximum level. That's almost impossible to do with a digital meter. But if you're using an analog meter, you can watch it. You're up here tuning your circuit, and you see when it hits peak, and you can see exactly when it starts what. So if you're in communications and you're dealing with tuned circuits, you probably need an analog meter. And that's it, guys. So that's electricity. We're going to start into chapter 1 of the textbook next class. And hold up. There is a topic quiz on electricity in Blackboard. So the topic quiz for basic electricity will be due. What we do is when we finish the lecture, so we finish this lecture, we let y'all have 7 days to get that in. Right? You understand? So that means this needs to be done before next what? Monday. Huh?
Next month.
Yeah, before next month. Before class, start of class on that.
It's under topic quiz.
No, well, no, it's under the
Chapter, and then keep on chapter 1, then
Are we okay?
No, I need to see it because you said we weren't even in the book yet.
I just know some of them say topic quiz on Blackboard. And some
Yeah, it depends on how many. We don't have a lot of topic quizzes in this class, so we don't give it its own button.
Let's do Friday.
Let's do Friday.
First week assignment.
First week assignment.
Code, safety evacuation, and facilities.
What was
You know,
due?
the typical stuff. Yeah.
So what we do in this class, the topic quizzes for this class is inside the lab book. They're called chapter quizzes. So when you do a group of labs inside that chapter, you're going to have a quiz at the end of that. So that's why those quizzes are not online. This right here is not in the lab book. Y'all understand? Yes or no? So that's why this is the only one that's going to be on Blackboard. So as soon as we get Blackboard up, so we select the class. Yeah, and then over here under course content. So course content. And then what are we dealing with? Basic electricity, right? All the other ones are labeled for chapters. So basic electricity, this is where your PowerPoints are going to be at. So if you need to go back, and there's a lot of information in these PowerPoints because we don't have a book. And right here it says what? Topic quiz.
Says there's no content.
Oh, then it's not available. Let me go back and make it available. Let me use my mouse. I'm gonna have to get out my buttons. Oh, there it is. Let's see if I can get to it. Well, guys, it's not in there. I'll have to find it and upload it. I'll do it in the morning. Yeah, I've got it turned on so I can see everything. So, but it will be. So see, I can hide stuff, but that's called edit mode, and my edit mode is turned off. So I should be able, if it was in there, I should be able to see it. See what time it is. I might can get it up there right now. So let me go to assessment test.
Just read back on that board.